Alloys. Alloys are simply mixtures of metallic elements or um, a combination of more than one metal to create effectively a solid solution or two metals that are dissolved in each other. Now, it's possible to make alloys out of a lot of different substances, but some of the well-known ones, such as bronze or brass, were known to ancient peoples. And they noticed that when you take copper and combine it with tin or zinc, you can make an alloy that is much stronger and harder than the original metals. And these allow you to make better plows or tools that can be quite useful. So in the case of bronze, this is actually just a mixture of copper and tin. Now, tin on its own is a very malleable element. It's very weak. You can bend it or move it around quite easily. But when you add copper to it, it gets a lot stronger. And you probably have seen various statues that have been made of bronze. And it has a very appealing color to it, and it tends to weather nicely. Now, a lot of alloys, they tend to have, well, bronze tends to have way more copper in it than it has tin. The copper content will likely be above 80%, and then whatever the balance is tin. But probably more like 88 to 90% copper and the rest being tin. There's also brass, which was known for a very long time. And this again is a copper-based alloy, but in this case you use copper and zinc. And you still have more copper in there, but the proportions is more like 2 to 1 in this case. Now, another alloy that we're very familiar with is steel. Now, steel is an interesting alloy because it is between iron and carbon. And you don't need much carbon inside of the steel to cause it to be a lot harder. And as you increase the hardness, you also increase the brittleness of the steel. Now, there are other steels than just iron and carbon. You can also add nickel or chromium to the steel. And if you get the proportions right, you can make a stainless steel, a steel that resists rusting. And those include chromium in them. But let's just go with the alloys that we have right here and talk about what they actually look like when we combine these two substances together. Particularly, let's look at brass and steel. With brass, copper and zinc are almost the same size to each other. The atoms have very, very similar atomic radii. They're right next to each other on the periodic table. And so since they are right next to each other and they're very similar, they're called a substitutional alloy. Now, a substitutional alloy will have the zinc take the place of a copper atom. So if you can imagine that we have a copper metal, and then we just take one of the copper atoms out and we stick in a zinc in its place. Well, we're going to do that in lots of different areas along this, and when we do, we'll make our alloy, and that's a substitutional alloy. That is, the zinc is taking the place of some copper in it. Now, with steel, it's a different story because iron is a lot bigger than carbon, quite a bit bigger. So, if we were to place or completely remove an iron atom and then try to put in a carbon, there would be too much room. So, what happens is that the carbon sits in the spaces in between the iron atoms. So if we were to draw this out, we would have iron atoms sitting something like this. I'm just simplifying this down. Now, a carbon atom is small enough that it will sit in this middle space right in there. Now, when it sits in there, it will distort the structure of this a little bit. It will push these apart or cause a little bit of stress on there. And that's why the steel gets harder, because there's this carbon inside. Now, usually steel only has a very minute amount of carbon, only maybe 0.5%. Some of it has more, some has less, but somewhere around in there. Now, this space in between the atoms is called the interstitial space. I forget how to spell interstitial. So this is an interstitial alloy. It sits in the middle of the little spaces. Now, what's the main driving force, or how could you figure out which kind of alloy is likely? Well, again, it has to do with the sizes. So when we have something where the size between the two alloyed materials is quite different, right? We have a much larger iron, we have much smaller carbon, then we're likely to have an interstitial alloy. But if the size of the alloyed components are very similar to each other, then we'll probably have a substitutional alloy.